So welcome back. As we were talking about in the last video, if you have any regular polygon, then you can use this formula right here to find the area of it. You only need the apothem and the perimeter. So what we're going to look at in these next few problems is what if you're missing something? What if you can't find the apothem or the perimeter? What if you're not given enough information? How would you figure out what's missing? And then remember, we can use that formula. So these first ones we did, we had the apothem. Remember, the apothem is a little height. We also had one side, so all I had to do was just plug it into that formula, being very careful of the perimeter. If I take a look at this example right here, I only have one side. So if I'm going to use that formula, area equals 1/2 the apothem times the perimeter. I have the perimeter. If one side is 6, all sides would be 6. So 6 times 3 would make the perimeter 18. What I'm missing is the apothem. I need that part right there. Okay, if I take a look within this triangle, remember that the apothem is like a mini height. Ask yourself, how many of these little triangles could you fit inside of this triangle? So that would be, there's 1, 2, 3, 4, that's 5 and 6. So if you notice a triangle with 3 sides, I could fit 6 mini triangles inside of it. So think like 3 times 2. And I'm just going to go back and show you real quick on another one. Again, this pentagon, how many of these mini triangles could I fit inside? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this pentagon had 10 mini triangles. So like 5 times 2 would tell you 10 mini triangles. A triangle 3 times 2 would tell you 6 mini triangles. And if I look at this hexagon, 6 sides, 6 times 2, I should have 12 mini triangles. So if I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's my 11 and 12. So take your number of sides, multiply it by 2, and that's going to tell you the number of mini triangles. Okay, back to this. There's 6 mini triangles, all stemming from the center of our shape. The center all the way around would be 360. If I divide that by the number of mini triangles, that's going to tell me all those angles that I would have. So all the way around would have been 360. I could do 6 mini triangles. So 360 divided by 6 would make this top angle right here 60 degrees. And if it's the apothem, mini altitude, that would be 90. This is a 30, 60, 90 hiding within here. And I could do that with any of these to find the angles and create a right triangle and then use that to help me solve. So if we just went back and looked at this pentagon, all the way around would be 360. We said there were 10 mini triangles, so 360 divided by 10 would make this little angle right here 36 degrees. And then that's going to start helping us with solving things here in a second. Because if I go back to this triangle, I had the perimeter. The perimeter is 18. Remember, 6 all the way around would make that perimeter 18. I found this angle right here to be 60. That's a 30, 60, 90. And I know this piece right here, if the whole side is 6, that piece right there would just be 3 because it would be half of 6. And then I could solve for x using my 30, 60, 90 chart because I have a 30, 60, 90 triangle. So if I set up my 30, 60, 90 chart, they should still be up on the board. I get 1, root 3, and 2. 6 is across from 60. That's the long leg. I want the apothem, which is across from the short legs. There's my x. I don't need the hypotenuse. Remember, the only reason I'm using this chart is back to this. I'm trying to find the area of it. I need the apothem. I know the perimeter is 18. I need the apothem. So I'm going to cross multiply, and we get x root 3 equals 6. Remember, you can't leave it like that, so I'm going to divide both sides by root 3. So then I have 6 over root 3. Oh, I messed up, y'all. My bad, my bad. It shouldn't be a 6. It should be a 3 because it's half of it. I knew I went wrong somewhere along the way. I blame the coffee. This is 3 because this whole thing was 6. So this piece right here would just be 3. My bad. So 3 over root 3. But that's not your answer. Multiply the top and the bottom by root 3, and you get 3 root 3 over 3, which just ends up becoming root 3. So back up here, x was root 3. Now you know the apothem, so you can go back to your formula. Area equals 1/2. The apothem was root 3, and the perimeter's 18. Half of 18 is 9, so our area would be 9 root 3 units squared. And what we're going to do is we're going to look at a few more. What if you're missing something? Like, how would you find it? So let's take a look at this next one. This is a hexagon. Remember when 8 goes to the corner like that? That's the radius. Okay, so I have a regular hexagon. I want to find the area of it. I can use that formula. Area equals 1/2 little a capital P. But I don't know the apothem and I don't know the side. So I can't really use that formula yet. I'm missing some things. I need the apothem. I need this piece. I also need to figure out what's the side. Now, if you remember with the hexagon was special because a radius and a side in the hexagon are the same thing. So if the radius is 8, one of the sides would be 8, which would make the perimeter 8 all the way around. So 8 times 6 would be 48. What I'm really missing now is the apothem. Okay, now hexagons work specially because 360 all the way around divided up by all of those mini triangles, it works out very nice and neat. So if we go back, let's just look at the last one for an example. These 12 mini triangles, so 360 divided by 12 is going to make all those mini triangles 30. So I have 30, 60, 90s again. But what makes the hexagon so nice is that your radius and your side are the same. So to get the apothem, all you have to do is just half your number. So think, if this is the hypotenuse, my short leg would be 10. So I have 20, 10. How would I find the long leg? 10 root 3. So back to this one. If my hypotenuse is 8, 360 divided by, remember that there were 12 mini triangles. 360 divided by 12 would make this 30. I know the short leg would be half of 8, which is 4. This would be 60. What would that make the long leg? 4 root 3. And that rule works for hexagons only. So the apothem would be 4 root 3. So hexagons are nice because you can kind of use that little shortcut where the radius and the side are the same and the apothem would just be half of it with the root 3 because it's the long leg. So area equals 1/2. The apothem was 4 root 3. And the perimeter, we said 8 all the way around was 48. Half of 4 is 2. And then just ask yourself, what's 2 times 48? What's 48 plus 48? And that would be 96. Don't forget about the root 3. So 96 root 3 units squared. And that's it for that one. Now, if we take a look at these last two, I have a problem on both of them. On this one, I have the side. So I can tell you the perimeter, 20, it's a pentagon, 20 times 5, the perimeter is 100. But in order for me to use that area of a regular polygon, I'm missing the apothem, okay? If I look over at this other one, I have the apothem. What I'm missing is one of the sides. And if I count all the way around, then I know this is going to be 9 sides, a nonagon. Remember that 9 sides would create 18 mini triangles. So a nonagon would have 18 mini triangles, and that's going to come back in just a bit. So let's take a look at this pentagon. I have the perimeter. What I need is the apothem. So if I sketch in a right triangle here, a lot of Unit 6 goes back to Unit 5. And if you think back to Unit 5, there was a way to find a side of a triangle if I only had one side, and that was trig. Remember, if I have an angle and a side, I can find a missing part. All I needed was an angle and a side. So in this mini triangle, I know that this piece right here would be 10 because it would be half of 20. If I can get one of the angles in here, then I can do trig. And I could figure out what the apothem is. Because remember, in a right triangle, if I have an angle and a side, I can do trig. Goes back to the mini triangle thing. If this is a pentagon, this pentagon would have 10 mini triangles because 5 times 2 is 10. So it would have 10 mini triangles. So all the way around would be 360. So 360 divided by 10 would tell me this angle right here, because 360, 10 mini triangles, 360 divided by 10 would tell me this angle is 36 degrees. So I can do trig now. So remember with trig, if I redraw that triangle, trig revolves around your acute angle. So there's your x, there's your 10. I want to circle my angle, start labeling. 10 would be opposite. X would be the adjacent. If I have opposite and adjacent, I would use tangent. And remember that these formulas are on the board and you don't have to memorize them. So tangent of 36 equals 10 over x. Now from here, if you still have your pink paper, great. Go to your pink paper, figure out what tangent of 36 is. So go look it up on your chart. So tangent of 36 was 0.7265. Remember, whenever x is high, we multiply. Whenever x is down, we divide. And I would do the bigger number first. Okay, that's if you have your pink paper. If you don't have your pink paper, then you need to make sure that your calculator is in degree mode. And then you can do 10 divided by tangent 36, figuring out what that is. Or for those of you with your paper, 10 divided by 0.7265. Either way, we're going to get that x is about 13.76. And I'm going to go out 2 places I don't want to round just yet. Now, I know that seems like a lot of work, but remember, this part, I'm just going to plug into my formula. I had to do all that work because I was missing the apothem. I found the apothem. I used trig. The apothem was 13.76, so now I can go back to my formula. So area equals 1/2. I used trig to get the apothem at 13.76, and the perimeter was 100. So area equals, I could just do half of 100 is 50, so I could do 50 times 13.76, and we get 688 units squared. Where you have to be careful on these problems is if you only have one thing. So on these 4 examples, I had to do a lot of extra work because I only had the side. I was missing the apothem. I only had the radius. I didn't have the side or the apothem. On this, I had the side. I needed the apothem. And on this one, I have the apothem. I need a side. And on these 2, I had to do trig because they weren't special. If they're a 30, 60, 90 or a 45, 45, 90, great. Use your chart. Back up here, if you can do Pythagorean theorem, do Pythagorean theorem. But on these last 2, I just didn't have enough information. So taking a look at this one, I know the apothem. The apothem is 2.5. What I don't have is the perimeter. So I'm going to create that mini triangle again. I'm going to find that angle, and that angle is going to help me get this x down here. And that's going to help me find the side, which will lead to the perimeter. So in order for me to do trig, I can't do Pythagorean theorem. Maybe it's a special right triangle, but I need to figure out what's this angle right up here. Okay, if you remember that all the way around was 360, the nonagon would have 18 of those mini triangles. So 360 divided by 18 would make this little angle up here 20 degrees. Okay, I'm going to circle my angle, label x would be opposite, 2.5 would be adjacent. So I'm going to do tangent again. But this time x is up high, so I'm going to multiply. And make sure that your mode is in degrees. Because if you do it correctly, you should get that x is about 0.91 if you multiply because x is up high. But remember, that's only this piece. The whole side would be 0.91 times 2, which would be 1.82. And because it's a nonagon, 1.82 times 9 would make the perimeter. 1.82 times 9 would be 16.38. And then from there, I can just go to the calculator and type it all in. And then I'm going to go ahead and round to one decimal place and say 20.5 units squared. You don't have to memorize that formula. You don't even have to memorize the little triangle rules. You just have to know how to use it. So be careful on those ones where you're missing something, and good luck on your practice.